Yeah. Yeah, hello students, let us discuss today some more points about ellipse. Okay, previous questions, previous year questions with solutions we can discuss today. Mainly we can focus today on questions. Yeah, hello students, let us discuss today some more points about ellipse. Yeah, so if we come to the topic overview is today what is the position of a point with respect to the ellipse and what is the position of a line with respect to the ellipse and what are the tangents. What are the tangents? Yeah, tangents to the ellipse. Today we can discuss in this session. This what you are seeing on the screen, that is a Spark Academy app. So download the app for great discounts on our courses like JEE Mains, JEE NEET and EAMCET. Yeah, here in this academy, in our academy, they can provide us study materials like free handwritten notes, free study materials, previous year questions, free mock test. Right, let us come to the topic. Today's topic is a position of a point with respect to ellipse. Okay, right. So, what is the equation of the ellipse? Equation of the ellipse is x square over a square plus y square over b square is equals to 1. And here, let us take a point. Let us take a point P of x1 comma y1. So we have to know the position of this point on this ellipse. So where it is it on the ellipse or it is outside the ellipse or it is inside the ellipse? For that we need a notation called S, where S is x square over a square plus y square over b square minus 1. This is S. So here we have to calculate what is S11. What is S11? x1 square over a square plus y1 square over b square, which is minus 1, which is, yeah, this is S11. Now how to decide the position of a point? Let us find out this S11 if this S11 is greater than 0. If this S11 is greater than 0, then then the point is outside the ellipse. If this S11 is equal to 0, then the point is on the ellipse. If this S11 is less than 0, then the point is inside. Then the point is inside the ellipse. Then the point is inside the ellipse. So it is also like a circle and parabola. What we have learned in the circle and what we have learned in the topic parabola, same thing here also we can learn. Clear? Let us try to change the color of the ink. Okay. So position of a point is clear, I think. The next one is position of a line. Next one is position of a line. So here, position of a line. Right, this is ellipse. Now there is a line. There is a line L. It is outside. Next, the line L touches the ellipse at only one point. Next, the line touches the ellipse at two different points. So here it is called just line. Line outside the parabola. Line outside the ellipse. And here it is called tangent. Tangent to the ellipse. And here it is called secant to the ellipse. Secant to the ellipse. Now let us take the standard form of the ellipse, x square over a square plus y square over b square, which is equals to 1. X square over a square plus y square over b square, which is equals to 1. Now there is a line called y is equals to mx plus c. There is a line y is equals to mx plus c. Now when do we say this line? When we say this line is outside the ellipse, or it is tangent to the ellipse, or it is secant to the ellipse. Okay. For that we have to do x square over a square plus y square. Here y is nothing but mx plus c, which is a whole square, divided by b square, which is equals to 1. Then here we have x square b square plus a square times m square x square plus c square plus 2mcx, which is equals to a square and b square. Now let us gather all x square terms. Here b square is coefficient of x square is b square, and here it is a square m square times x square, and next x term 2mc a square x. Next constant term, that is a square c square minus a square b square, which is equals to 0. So here we got a quadratic equation in terms of x. So how do we decide from this quadratic equation when the line is tangent or secant or outside? That depends upon the discriminant, where the discriminant is a delta equal to b square minus 4ac. Right? Let us find out this discriminant, and here particularly we need, okay, once again, if this delta is greater than 0, then the line is outside. If this delta is equals to 0, the line will become tangent. If this delta is less than 0, this line will become secant. Now let us try to see when this line will become tangent. When this line will become tangent. Actually, that is our next concept. Let us try to do from here only. So b square minus 4ac, which is equals to 0, right? That means what? That is b square equal to 4ac we are getting, right? What is b square here? B square is 4 am square c square a power 4 equal to 4 times b square plus a square m square times a square c square minus a square b square, right? So here 4 and 4 gets cancelled. What is left? M square c square a to the power of 4, which is equals to b square a square c square minus a square b power 4 and plus a power 4 m square c square and minus a power 4 minus a power 4 m square and b square. So you see here a power 4 c square m square, a power 4 c square m square gets cancelled both the sides, and the remaining terms, if we simplify, what are we getting? Here you see a square b square c square is there, a square b square c square is there, and here we have minus a square b power 4, and here it is a power 4 m square b square we have. So what is required actually for us? We required what is c. Then let us calculate c value here by writing like a square b square c square, which is equals to a square b to the power of 4 plus a power 4 b square and m square. So here a square is taken out and cancelled, and b square also taken out and cancelled. Then we have c square is equals to, b square plus, here b square is left, and in this b square already out, and only a square m square is left. So finally c is equals to what we have? C is equals to a square m square plus b square under root of plus or minus. C is equals to plus or minus under root of a square m square plus b square. Okay, this is the value of c. This value of c is also called as condition for tangency. This value is also called as condition for tangency. Here we have taken delta equal to 0. That is the reason we got this. If delta is greater than 0, what do we get? C must be greater than plus or minus under root of a square m square plus b square. If delta is less than 0, that means c less than under root of a square m square plus b square, then it is a secant line. So in this case particularly, if c is equals to under root of m square a square m square plus b square, then the line y equal to mx plus c represents tangent line. Got it? This is the condition for tangent line. Here particularly we are talking about position of a line, right? If c is this, then we can get a tangent line. If c is greater than under root of a square m square plus b square, then we can get a line outside, Next, if it is c value is less than under root of a square m square plus b square, then we can get a secant line. Clear? Condition for tangency. Yeah, in the above case, what we have discussed, x square over a square plus y square over b square equal to 1, and the point is right. line we have taken. No? Yeah, line is y equal to mx plus c. Then we have solved, right? If we solve, what we have, we got to c is equals to plus or minus under root of a square m square plus b square. This is called as condition of tangency. Condition of tangency. Okay, now again no need to solve. C is equals to plus or minus under root of a square m square plus b square is called condition of tangency. Then in this case, what is the equation of the tangent? Y is equals to mx plus or minus under root of a square m square plus c square. This is called equation of tangent to the ellipse. Okay, equation of tangent in point form. Equation of tangent in point form means that point should be on the ellipse. Suppose here we have a point, let it be x1 y1, right? Point should be on the ellipse. So here what is ellipse? Here x square over a square plus y square over b square equal to 1. Now I differentiate this with respect to x. What do we get? Here it is what 1 over a square times 2x into 2x plus 1 over b square into 2y dy over dx, which is equals to 0. Then we can get dy over dx is equals to minus 2x divided by 2y into b square over a square. So here 2 and 2 gets cancelled. At x1 y1, what do we get at x1 y1? Slope of a tangent we can get. At x1 y1 we can get a slope of a tangent. Slope of a tangent is equals to minus x over y. That means minus x1 over y1. Okay, minus x1 over y1 times b square over a square. This is slope of tangent. Okay, and if we know the slope of a tangent, then y minus y1, which is equals to m times x minus x1. So y minus y1, which is equals to m minus x1 over y1 times b square over a square into x minus x1. So y1 a square into y minus y1 is equals to minus x1 b square into x minus x1. So if we simplify this, you can get tangent line. Okay, now next, parametric form. So parametric form, a cos theta comma b sin theta. This is the point on the ellipse. So just now we have done x square over a square plus y square over b square, then b square x square plus a square y square is equals to a square b square. Then this is a 2x b square plus 2y a square into dy by dx is equals to 0. Then dy by dx is equals to minus 2b square x divided by 2a square y. 2 gets cancelled. Then dy by dx at a point a cos theta comma b sin theta. This is equals to minus b square into a cos theta divided by a square into b sin theta. So what we are getting here, a and a gets cancelled, b and b gets cancelled. So we get negative b over a into cot theta. This is the slope. Then what is the equation of the tangent? Y minus y1, that is b sin theta which is equals to slope minus b by a into what it is, cos theta over sin theta, no? Cos theta over sin theta into x minus x1, that is a cos theta, ay sin theta minus ab sin square theta minus bx cos theta plus ab cos square theta. So here what we have, b cos theta x plus a sin theta y plus ab, which is equals to 0. This is the equation of a tangent in parametric form. What it is? Equation of a tangent in parametric form. Got it? Next, let us see what is the slope form. What is the slope form? Slope form already we have derived, right? What is that? Y is equals to mx plus c. So y is equals to mx plus, what is a c, sir? Under root of a square m square plus b square. This is called a slope form. Slope form of a tangent, right? That is today's topic. What we have learned today: position of a point with respect to ellipse, position of a line with respect to ellipse, what is tangent to the what is tangent to the ellipse, and what are the different forms of the tangent with respect to the ellipse: point form, parametric form, and slope form. Okay, right. Yeah, what is this? This is a link in description. Yeah, this is about the Spark stores are here. What we have in our Spark store: long-term courses 2023, 2022 and 23. Next, crash courses for 2022 and 23. Next, mock test and previous year question paper solutions. Next, full length test, study materials, and exclusive training for JEE Mains, NEET, EAMCET and IIT Foundation. High quality courses with great offers and discounts. Okay, don't be late, try to buy it. Admissions are open, join now. This is the, yeah, what you are seeing here, this is this is offline classroom atmosphere. What is there on the screen? It is offline classroom atmosphere. Here we have short-term crash course, we have short-term crash courses, and we have long-term or short-term coaching. For short-term or long-term coaching, timings are 10 a.m. to 4 p.m. and for classroom coaching, offline classes. Next, regular coaching, evening 6 p.m. to 9 p.m. And we have the branches in Narayanaguda and Mehedipatnam, right? Admissions are open, join now. Okay, these are the courses, online classes, live sessions, regular classes in live, right? If you are unable to attend the offline classes uh, due to any urgency, then we can attend the classes in online also. And these are the statistics. Next, our methodology. What we can follow here, we can first we can go through the basic concepts, then we can try to teach shortcut methods, then all model questions, then exercise questions, and then previous year questions, chapter wise test, weekend test, grand test. Okay, finally test analysis. Right, let us try to solve the questions. Let us try to solve the questions. Here, what is question number 1? Let L be a tangent. Okay, now let L be a tangent. Once again. Alright, okay, let us start solving questions. Let L be a tangent line to the parabola y square equal to 4x minus 20 at 6, 2. If L is also tangent to the ellipse x square over 2 plus y square over b equal to 1, then the value of b is equal to, see here, L be the tangent line to the parabola y square equal to 4x minus 20 at 6 comma 2. So first try to write, one second, we can change the color. Okay, so given parabola. What is given parabola here? Given parabola is y square equal to 4x minus 20. Given parabola y square equal to 4x minus 20. And we need a tangent at a point 6 comma 2. We need a tangent at a point 6 comma 2. So first let us find out the slope. 2y dy over dx is equals to 4, then dy over dx, which is equals to 2 over y. So from this, slope of a tangent is nothing but 2 by 2, that is 1. Then equation of a tangent y minus y1 is equals to m times x minus x1. So y minus y1 is 2, m is 1, x minus x1 is 6, y is equals to x minus 4. This is the tangent line for the given parabola y square equal to 4x minus 20. It is also, this is also a tangent to an ellipse x square over 2 plus y square over b equal to 1. Right? Generally, what is the tangent line for this? Y is equals to mx plus under root of a square m square plus b square. So we got y is equals to x minus 4. Then by comparison we can get m is equals to 1 and minus 4, which is equals to under root of a square m square plus b square. So 16 is equals to a square m square plus b square. Okay now. And 16 is equals to a square is 2, m square is 1, b square is b. Then 14 is equals to b. The value of b is 14. Then the value of b, they are asking, the value of b is 14. Clear? Right. Next question, question number 2. If 3x plus 4y equal to 12 times the square root of 2 is a tangent to the ellipse x square over a square plus y square over 9 equal to 1, for some a belongs to r, then the distance between the foci of the ellipse is. So you can look at the line here, given tangent line. What is given tangent line here? 3x plus 4y, which is equals to 12 times the square root of 2. It is nothing but y is equals to negative 3 over 4 times x plus 3 times the square root of 2. And what is given ellipse? X square over a square plus y square over 9, which is equals to 1. For this ellipse, y is equals to mx plus square root of a square m square plus b square is the tangent line. This is given tangent line and this is the standard form of the tangent line to the ellipse. So from this we can get m is equals to negative 3 over 4. M is equals to negative 3 over 4 and c square, that is 3 times square root of 2 whole square, 9 times 2 18, which is equals to a square m square plus b square. We know a square is a square only, m square is 9 over 16 plus b square is 9. From this we can get a square times 9 over 16 is equals to 9, then a square equal to 16, then a is equals to plus or minus 4. Okay, then what is the ellipse here? X square over 16 plus y square over 9 equal to 1. Here a is greater than b. A is greater than b. So what it is? Horizontal ellipse. Then we can get b square is equals to a square times 1 minus e square. Here b square is a 9. 9 equal to 16 times 1 minus e square. 9 over 16 is equals to 1 minus e square. Then e square is equals to 1 minus 9 over 16. 16 minus 9, 7 over 16. Then e is equals to square root of 7 over 4. Right? Eccentricity e is equals to square root of 7 over 4. What they are asking, then the distance between the foci. Therefore, distance between the foci, which is equals to 2a, 2 times a value 4, e value square root of 7 over 4. 4 and 4 gets cancelled. We are getting 2 times square root of 7. But we are getting 2 times square root of 7. That is the final answer. Is it clear? Next one. The length of the minor axis of an ellipse in the standard form is 4 over square root of 3. 4 over square root of 3. Length of the minor axis. Length of the minor axis given. Length of minor axis. Sorry. Length of minor axis. Sorry. Length of minor axis is equals to 4 over square root of 3. If this ellipse touches the line, and you see here length of the minor axis along y-axis. Minor axis along y-axis means it is horizontal ellipse. So this is 2b. From this, what is b? b is equals to 2 divided by square root of 3. If this ellipse touches the line x plus 2y equal to 4, if this ellipse touches the line x plus 6y equal to 8, x plus 6y equal to 8. Ellipse touches the line, that means what it is the tangent line. Y is equals to negative x over 6 plus 8 over 6. This is a tangent line. So let us take the ellipse is x square over a square plus y square over b square equal to 1, and the tangent line is y is equals to mx plus square root of a square m square plus b square. Okay, so from this we can get m is equals to minus 1 by 6, and c square, this is what's that, 4 over 3 whole square, 16 by 9, which is equals to a square m square plus b square. So 16 by 9 is equals to a square m square 1 over 36 plus b square 4 over 3, and then 16 over 9 minus 4 over 3 is equals to a square over 36 then 16 minus 12. 16 minus 12 is 4. 4 over 9 is equals to a square over 36. Then a is equals to 4. The value of a is 4. So we have a value as well as b value. What is asking here, eccentricity. Already minor axis is along y axis, so it is horizontal ellipse. Then we can get b square is equals to a square of 1 minus e square. So b square is 4 over 3. A square is 16. 1 minus e square 4. So 1 over 12 is equals to 1 minus e square. Then e square is equals to 1 minus 1 over 12. Then e is equals to square root of 11 over 12. E is equals to square root of 11 over 12. Right? Next question. Let a comma b and lambda be positive real numbers. Okay, a comma b and lambda. A comma b and lambda are the positive real numbers. Suppose P is an endpoint of the lattice rectum. Suppose P is an endpoint of the lattice rectum of the parabola. So here parabola is y square equal to 4 lambda x. Y square equal to 4 lambda x. Then here lattice rectum lambda comma 0. One end. This is lambda comma x value lambda. Y square equal to 4 lambda square. Then y is equals to 2 lambda. So 2 lambda comma 2 lambda. This is P. P is an end point of an lattice rectum of the parabola y square equal to 4 lambda x. And suppose the ellipse x square over a square plus y square over b square equal to 1 passes through the point P. Okay. So this ellipse is passing through this point P. If the tangents to the parabola and the ellipse at the point P are perpendicular to each other. Okay. So y square equal to 4 lambda x. That means what? Y1 is equals to 2 lambda times x plus x1. So y1, that is y times 2y or 2 lambda, is equals to 2 lambda times x plus x1. This equals to 2 lambda gets cancelled. Y is equals to x plus lambda. This is what tangent to the parabola. And tangent to the ellipse is y is equals to mx plus under root of a square m square plus b square. So y is equals to mx. Y is equals to mx. Here y is what? 2 lambda. 2 lambda is equals to mx. M lambda plus under root of a square m square plus under root of m square a square. But here y equal to mx plus under root of a square m square plus b square. What it is actually, this is a slope form. But slope form is required over here. Slope form is not required. Slope form is not required. What is required? A point form. What is point form? X1 by a square plus y1 by b square is equals to 1. So x1, that is lambda x over a square plus 2 lambda y over b square is equals to 1. Lambda x over a square plus 2 lambda y by b square equal to 1. So if we try to simplify this, what do you get? You can get y is equals to minus lambda by a square x plus 1, and this 2 lambda b square, if we send this side, this whole times b square over 2 lambda. So exactly what it is, y is equals to lambda lambda gets cancelled, minus b square over a square, and here 2 lambda, no, 2 left, and x, and plus b square over 2 lambda, right? If we try to how these two are there, these two are perpendicular to each other. Here the slope is 1 and here the slope is minus b square over 2a square. As they are perpendicular to each other, m1 times m2 is minus 1, m1 is 1, m2 is minus b square by 2a square, which is equals to minus 1. So we are getting b square equal to 2a square. What are we getting? B square equal to 2a square. What they are asking, eccentricity of the parabola. So here b square is greater than a square. B is greater than a. B is greater than a means vertical it is. Vertical ellipse. For vertical ellipse, a square is equals to b square times 1 minus e square. So here a square is equals to b square is 2a square 1 minus e square. Then 1 by 2 is equals to 1 minus e square. E is equals to 1 over square root of 2. So eccentricity of the ellipse is 1 over square root of 2. This is question number 4. Clear? Right. Next question number 5. This is advanced question. Suppose that the foci of the ellipse x square over 9 plus y square over 5 equal to 1 are f1 comma 0 and f2 comma 0, where f1 greater than 0 and f2 less than 0. Let p1 p2 be the two parabolas with common vertex at 0 comma 0 and the foci at f1 comma 0 and 2 f2 comma 0 respectively. Okay, let us see one by one. First, what they have given here. Suppose that foci of the ellipse. So what is given ellipse here? X square over 9 plus y square over 5, which is equals to 1. So a value greater than b. A value greater than b means what? Horizontal. What it is? Horizontal ellipse. For horizontal ellipse, b square is equals to a square times 1 minus e square. What is b square? 5 equal to 9 times 1 minus e square. So 5 by 9 equal to 1 minus e square. E square is equals to 1 minus 5 by 9. E is equals to 4 by 9. So E is equals to plus or minus 2 by 3. E is equals to plus or minus 2 by 3. Here f1 comma 0 and f2 comma 0 both are foci, and f1 is greater than 0 and f2 is less than 0. So what is one second, foci plus or minus uh, what happened? We came to next page, huh? Okay, there what we got? We got eccentricity value. We got what is eccentricity? Eccentricity is equals to 2 by 3. What they said, they have foci, it seems. What are the foci there? Foci is plus or minus a e comma 0. Foci is plus or minus a e comma 0. Once again, 1 second, students. Yeah, we are here. All right. All right. So foci is what? Plus or minus AE comma 0, na? Yeah, plus or minus AE comma 0. So plus or minus, what is A value? 9. Eccentricity is 2 over 3 comma 0. So what we are getting? Plus or minus 6 comma 0. Plus or minus 6 comma 0. A square value 9, na? A value square root of 9. So both gets cancelled. This is only 2. So plus or minus 2 comma 0. These are the foci. And here f1 is greater than 0, f1 equal to 2, f2 is less than 0, f2 is equals to minus 2, right? f1 comma 0, 2 comma 0, f2 comma 0, minus 2 comma 0. P1 and P2 be the parabolas. P1 and P2 be the parabolas with a common vertex. Vertex is 0 comma 0. For both parabolas, vertex is 0 comma 0. And with foci at f1 comma 0 and with foci at f1 comma 0. For this foci is 2 comma 0 and 2f2, that is minus 4 comma 0 respectively. So here this is a, then we can get a y square equal to uh, what it is, a value 2 means 8x. Here a value minus 4, y square equal to minus 16x. Let t1 be the tangent to p1 passes through 2f2 comma 0. Here t1, what is t1? T1 is y1 is equals to 4 times x plus x1. This T1 is passing through the point 2f2 comma 0. 2f2 comma 0. What is 2f2? Minus 4 comma 0. Minus 4 comma 0. If we substitute minus 4 comma 0, if you, okay, let it be minus 4 comma 0. And next to T2. T2 is y1 is equals to minus 8 of x plus x1, right? So here at what point it is? f1 comma 0. f1 comma 0 means 2 comma 0 at 2 comma 0, right? So both the tangent lines also we got. If m1 is the slope of t1 and m2 is the slope of t2, then the value of 1 by m1 square plus m2 square, in the value of m1 square plus m2 square. So here m1 and m2 slopes they are asking, so compulsory slope form is required. Instead of taking point form, let us try to write slope form for this. What is the slope form for this? Y is equals to m1x plus a by m. This is a slope form. And for this, y is equals to m2x plus a by em2. This is a slope form because they mentioned here slopes, and these tangents are passing through the points minus 4 comma 0 and 2 comma 0 respectively. If it is passing through minus 4 comma 0, we can get 0 is equals to minus 4m1 plus a value. What is a value here? 2. 2 by m1. From this we can get m1 value. What is m1 from this? 4 m1 is equals to 2 by m1. And then we are getting m1 square is equals to 1 by 2. Okay. And here y is equals to m2x plus a by m2. Here a value minus 4. And it is passing through 2 comma 0. Then 0 is equals to 2m2 minus a minus 4 by m2. So 2 ones are 2 2s are. And then we are getting m2 square. m2 square is equals to m2 square is equals to 2 we are getting. m2 square is equals to 2 we are getting. Clear? Here m2 square is equals to 2, m1 square is equals to 1 by 2. m1 square is equals to 1 by 2 means 1 by m1 square is 2 again. m2 square is 2 again. So 2 plus 2, 4. Right? Finally the answer is 4. So see here, the concept is basic concept, but the question asked in advanced exam. That's why I have taken this question. Let us move to the next question. Yeah, question number 5. I have taken additional page because it is a lengthy solution, right? Right. Next question number 6. Passage question here. Question number 6 and question number 7 both are related to this. And here this is also advanced question, but the concept is basic concept. Almost the question is same. Almost the question is same as above question, but something is added. Something is added to the above question. You see here, let f1 x1 comma 0 and f2 x2 comma 0, x1 less than 0, x2 greater than 0 be the foci of the ellipse. So here also ellipse is given. X square over 9 plus y square over 8 is equals to 1. So here a is greater than b. What it is? It is a horizontal. As it is horizontal, we can get b square is equals to a square times 1 minus e square. Then b square 8 is equals to 9 times 1 minus e square. 8 by 9 is equals to 1 minus e square. E square is equals to 1 by 9. E is equals to 1 by 3. Eccentricity is equals to 1 by 3. After getting eccentricity, foci we need to calculate. Plus or minus AE comma 0. So plus or minus A value 9, E value 1 by 3. So what we are getting here? Plus or minus 3 comma 0 we are getting. Plus or minus 3 comma 0. Same mistake we have done now. What we have done in the last solution. Yeah, this is a 3 actually. 3 gets cancelled 1. So plus or minus 1 comma 0. Here f1 is x1 comma 0 and f2 is x2 comma 0. x1 less than 0, x2 greater than 0. x1 is less than 0, x1 is equals to minus 1 and x2 is equals to plus 1. Then the point f1 will be like minus 1 comma 0 and the point f2 will be 1 comma 0. Right, f1 f2 both the points we got. Suppose a parabola having vertex at the origin. Suppose there is a parabola having vertex at the origin and focus at f2 that is 1 comma 0. So what could be the parabola? Y square equal to 4x is the parabola. This parabola intersect the ellipse at point M. This parabola intersect to the ellipse at M in the first quadrant and at N and at point N in the fourth quadrant. Okay. So let us do like this. Ellipse. They are saying that this is M and it is N. This is y square equal to 4x. X square over 9 plus y square over 8 is equals to 1. Okay, now here the focus is 1 comma 0. Focus is 1 comma 0. This is what, sir? 1 comma 0 is f2, and here we have f1 minus 1 comma 0. The orthocenter of the triangle f1 comma mn. Okay, now we have a triangle like this. This is n, this is m. Here it is f1. What is f1? f1 is minus 1 comma 0. Then find out the coordinates of m and n. Find out the coordinates of m and n. Yeah. How do we get the coordinates of m and n? Where is m? M is on the ellipse and m is on the parabola. M is on the ellipse and m is on the parabola. So we can get m as 3 by 2 comma, yes or no? We can get 3 by 2 or not? What is 3 by 2 actually here? What is 3 by 2? One second. So here, what is ellipses are here? X square over 9 plus y square over 8 equal to 1. X square over 9 plus y square is 4x. 4x over 8 equal to 1. 4 1s are 4 2s are. X square over 9 plus x by 2 is equals to 1. Now if we take the LCM, what is the LCM? 9 is the LCM. X square, 18 is the LCM. 2x square plus 9x. 2x square plus 9x is equals to 18. 2x square plus 9x is equals to 18. From this, 2x square plus 9x minus 18 equal to 0. So 36 is the product, 9 is the sum. Then 2x square plus 12x minus 3x minus 18 equal to 0. 2x if we take common, x plus 6 minus 3 if we take common, x plus 6. Then x is equals to 3 by 2 or x is equals to under root of 6. X is equals to minus 6, sorry. So x is equals to 3 by 2 or x is equals to minus 6. X is equals to minus 6 means it is in third, but here it is not in third quadrant. X value is in first quadrant and fourth quadrant. So x is equals to 3 by 2 is final value. So the x coordinate of m is 3 by 2 and x coordinate of n also 3 by 2. Now what is the y coordinate? Y coordinate we have to calculate. We know that y square equal to 4x and y square is equals to 4 times 3 over 2. Y square equal to 6. Y is equals to square root of 6. So 3 by 2 comma root 6, 3 by 2 comma minus square root of 6. Minus square root of 6. And from F1, if we drop the perpendicular, this is one of the perpendicular from F1. Because here we need to calculate the orthocenter. Orthocenter is the concurrent point of altitudes. So here one of the altitude we have drawn from F1. Let it be some F1R. And next one more altitude we are drawing from M. This is from some MP. Okay. So this MP line slope we have to calculate. This MP line slope we have to calculate. And this MP line, how the line will be? The line is perpendicular to F1N. So first to calculate the slope of f1n. First to calculate the slope of f1 and n. Let us move to the next page. Here f1 is minus 1 comma 0 and n is 3 by 2 comma root 6. Am I correct? 3 by 2 comma root 6. N value 3 by 2 comma root 6. Yes, n value 3 by 2 comma minus root 6. Okay. Now slope calculate here. Slope of f1n, y2 minus y1 minus root 6 minus 0 by x2 minus x1. This is minus root 6 divided by 3 over 2 plus 1 minus root 6 divided by 5 over 2. 2 times the square root of 6 divided by 5. Okay, this is slope of f1n. Then a slope of MP. Slope of MP is what? 5 by 2 times the square root of 6. Then equation of MP. What is the equation of MP here? Y minus y1 is equals to m times x minus x1. Y minus y1. What is point m here? M point is 3 by 2 comma root 6. So y minus root 6 is equals to m. M is 5 divided by 2 root 6. X minus x1. X1 is 3 by 2. This is MP. And this MP and y equal to 0 is another altitude. Point of intersection of these two lines is negative root 6 is equals to 5 divided by 2 root 6 times x minus 3 by 2. Okay, so if we send this side, minus 12 over 5 plus 3 over 2 is equals to x. Minus 24 plus 15 divided by 10 is equals to x. So what we are getting, x minus 9 over 10. Then therefore orthocenter is equals to minus 9 over 10 comma 0. This is the orthocenter of what triangle? That is triangle F1MN. Right, this is the first question in that advanced exam. This is advanced exam 2015, I think. This is the first question under the paragraph. Next to second question. This is second question in that paragraph. Under the same paragraph, this is second question. If the tangents to the ellipse at m and n. So here, what is the equation of the ellipse? Once we can write here, x square over 9 plus y square over 8 equal to 1. Okay, now tangent at m and n. So already we know the point m 3 by 2 comma root 6 and point n 3 by 2 comma minus root 6. Both meet at r and the normal to the parabola at m meets the x-axis at q, and the ratio of area of triangle MQR to the area of quadrilateral MF1 and F2. Okay, tangents to the ellipse at M and N meet at R. So here we can draw the figure. So let us take it as M. Here it is N. So this is first tangent. This is second tangent. Both are meeting here. This is R. Okay, now that is R. And the normal to the parabola at M. Normal to the parabola at M here. This is for parabola. Normal to the parabola at M. Okay, for the parabola at M meets the x-axis at Q. So at here it is meeting x-axis at Q. Then the ratio of triangle, then the ratio of area of the triangle MQR, this MQR, and area of the quadrilateral, here F1 will be no M F1, like this, M F1 N F2. Oh, like this. This is quadrilateral. Okay, let us calculate one by one. First, let us find out what is R. So here m 3 by 2 comma root 6 and n 3 by 2 comma minus root 6. And here what is the line? X x1 by 9 plus y y1 by 8 is equals to 1. If we substitute the values, 3 by 2 x by 9 plus root 6y square root of 6y by 8 is equals to 1. Here the point of intersection is on x-axis, so x value is 0, y value is 0. Then what we have? 3 by 2 into 9x is equals to 1. Then we are getting x is equals to 6. X is equals to 6. So this point is 6 comma 0. R point is 6 comma 0. We got the coordinates of R. After getting the coordinates of R, let us try to calculate the Q. Then Q we have to calculate. No, what is Q here? Normal to the parabola at M. So what is parabola here? The parabola in this situation, the parabola is y square equal to 4x. Y square equal to 4x is the parabola. Then the point is 3 by 2 comma root 6. Then 2y dy by dx is equals to 2 times x plus, differentiation we are doing, right, equal to 4. Then dy by dx is equals to 4 by 2y, and then it is 2 by y. Then slope of tangent is equals to 2 by square root of 6. Then slope of normal is equals to minus square root of 6 by 2. Then equation of normal is equals to y minus y1, that is root 6, is equals to minus root 6 by 2 into x minus x1, that is 3 by 2. So simplifying, 2y minus 2 root 6 is equals to minus root 6x plus 3 times minus root 6x by 2. 2 send that side, huh? Okay. Then minus 3 root 6 by 2. So what it is finally? Finally it is 2y, okay, plus square root of 6x minus 2 root 6 minus 3 root 6 by 2 equal to 0. So 4y plus 2 root 6x, next 2 2s are 4, minus 4 minus 3 minus 7 root 6 equal to 0. So this is the equation of the normal. Equation of the normal is meeting x-axis at q. So y equal to 0. Then x is equals to 7 square root of 6 by 2 square root of 6. X is equals to 7 by 2. Then the point q. The coordinates of q are 7 by 2 comma 0. The coordinates of q are 7 by 2 comma 0. Okay, now everything we got. Now let us try to calculate the ratio. Area of the triangle MQR. Area of the triangle MQR divided by area of quadrilateral MF1 NF2, which is equals to half times MQ times MR. What is the distance between MQ? Distance between MQ is perpendicular, that one, okay. So square root of 6, and distance between Q and R. Distance between Q and R is 7 by 2 minus 6. 7 by 2 minus 6. Okay. Whole divided by half into. Here this is also area of the two different triangles, the above triangle and below triangle. So base is common, F1 to Q. F1 to Q is distance 2 into above height and below height. Above height 2 root 6, below height also 2 root 6. 2 root 6 plus 2 root 6. Above height and below height. One second. 6, 6. Height is a 6, only 6. Simplify this. So half and half gets cancelled. Square root of 6 into what is this? 6 minus 12 means 5 by 2 whole divided by 2 times 2 root 6. Root 6 cancel. So this is 5 divided by 8. 5 divided by 8. The ratio is 5 to 8. Okay. Okay, students. Thank you.